Math 265A, Cuesta College. I'm Joe Vasta, and we are going to cover 2.1. 2.1 is called the idea of a limit. We covered, no, guess already. Should I just stop the video and do this again? Nah, this is funnier. We covered this with our bug lectures, and we'll talk about limits and all that stuff. The average velocity in a time interval is related to a secant line, and the instantaneous velocity in a time interval is related to a tangent line. If you take a limit of slopes of secant lines, you can guess what the slope of the tangent line will be. And then, we had the t-axis and the s-axis. So instead of just waving my hands and saying, well, I think you should be able to handle the few homework problems that I assigned there, I'm going to go ahead and do an even problem and see if we can get this done here. Okay, so we have something where they ask us to do something. They ask us to complete the following table with the appropriate average velocities. Then make a conjecture about the instantaneous velocity at 2. So notice, look at the time interval. We have 2 to 3, and then 2 to 2.5, and 2 to 2.1. And so the time interval is getting smaller and smaller and smaller. The time is staying constant on the left-hand side, but on the right-hand side, it's getting closer to that time. And so we're going to look at average velocities. We're going to fill in the table, and then after we do that, we will then make a conjecture. A conjecture is the way of saying we're going to guess. So from 2 to 3, that's what we're going to do first. Average velocity. So how am I going to do that? Well, what am I going to put there? The average velocity, and notice they call the function s of t and not f of t. That's all right. I'm going to go s of the end time minus s of the beginning time all over 3 minus 2. So this is going to get a little complicated because I'm going to go negative 4.9, and then we have, so I'm plugging 3 into this function. So I'm going to go 3 squared plus 30 times 3 plus 20. Okay, so that's s of 3. Then I'm going to go minus, because there's a minus there. Minus, so remember the average velocity is displacement. That's what displacement is over the time. So now I'm going to go ahead and plug 2 into there. So I have negative 4.9, 2 squared plus 30 times 2 plus 20. Woo! And that's going to be subtracted. This is all going to be over 3 minus 2. So what I've done, I'm going to show you something kind of neat. It's my calculator. Wow, and you might not even be able to see what's on there. Okay, so that's what's on there right there, and I've just entered in exactly, now I put 3.000, and I'm going to show you why I did that. And everything that I put on there is right there. And then there's the minus part, and then I put this over 3.000 minus 2. I hit enter, and I get 5.5. So I just entered that into my calculator. 5.5 happens to be the average velocity in that time interval from 2 to 3. Now the function's a little bit more complicated than just t squared on the right hand side. And this is, and they've actually using meters and seconds. Sometimes they'll use feet. So this is meters per second. Okay, so 5.5 meters per second. And so when I go to do this again, okay, so I know this is really high tech. I'm going to do the same calculation for 2 to 2.5, and instead of putting 3 into this function, I'm going to put 2.5 into the function, and so I hopefully will get the right answer. So I'm going to go ahead and try to hold the calculator up. I know there's a glare off the window, and then I'm going to say this is 2.5, and all I'm doing is editing the line that I had. And this is going to be 2.5, and then that's 20, and then this is when I put 2 in there, 1 times 2, and then this is all going to be divided by, and then all I'm doing is I just have this TI-30X2S, so if you have a calculator like this, you can edit things, and it's not going to be 3 anymore, it's going to be 2.5. 2.5. And I think that's the last instance of 3, and I'm going to hit that, and I get 7.95. So look at this, 7.95 meters per second. I'm actually having people emailing me, and I can't add anybody else to the class until people drop. So a great way to get people to try to drop the class is in my videos to show this calculator thing again on this one, because then people are going to be like, I'm going to switch classes, this guy's boring, and that's actually what I want. So here's the calculator again. I'm going to go ahead and everywhere there's a 2.5, switch it to 2.1. Might be blurry on the video, I don't know. 2.1. And so that's the good thing about these calculators, where you can just use the buttons and do the last thing that you did. Edit it a little. So what is this? 2.1. 2.1. I'm getting 9.91 meters per second. Okay, so all I'm doing is doing the homework problem. I could keep doing this. I'm sure some of you are like, okay, Joe, we know you're editing the line. So when I did this one here, because I kind of did this one, pretty sure I did this one in advance, and what I ended up getting is 10.351 meters per second. And you know what these are actually describing physically? If you graph this thing, this would describe the slope of the secant line that connects time equals 2 with time equals 3, and then here's the slope of another secant line and the slope of another secant line, and they're supposed to be converging or getting closer and closer to something that we're going to make a guess at. So I did this one on the calculator. I got 10.3951 meters per second. And now that's all they wanted us to do, but I wasn't happy with that because, you know, like, what is my guess going to be? Is it going to be 11? Well, I don't know. So I went ahead and on my own, I just said, okay, I'll go from 2 to 2.0001. And I went ahead and put that in the calculator, and what I ended up getting is 10.39951 meters per second. So look at how this time interval is getting closer and closer and closer to from 2 to almost 2. Okay, so that's what we're doing. We're looking at the velocity at 2. So what guess would we take if we are taking the limit? That's what limit means. We're seeing where these guys are getting closer and closer to. Well, it looks like it's going to be 3, probably if you kept going it would be like 3999999. So it probably the limit is 10.4 meters per second for the instantaneous velocity at time equals 2. Now they're just kind of introducing you to the fact that, you know, things get closer and closer number-wise to something that we're looking for, but we're going to find a precise way of grabbing onto this thing called a limit. So I believe you get a few problems in 2.1, do your homework, and the next lecture will be 2.2.